respected dignitaries and educators. Today, I'm very thankful to all of you to present my research work in the front of you all peoples. First of all, I would like to say special thanks to my guide, Dr. Ganpat Joshi, Research Dean, Dr. Sumit Kumar, and Research Director, Dr. Pawan Sir. So today I am just to be presenting my thesis or complete research work throughout this journey of my PhD. I just to be identify some new areas in the field of the Vanet Communication. So today I am just to be present and entitle my complete throughout the work of this progress in the front of you all people. So now I have to start my PPT. Uh, thus, I start my PPT. The first I will just to be introduced about the topic that's to be novel hybrid optimization algorithm and route distribution among the routing protocols for the VANET using IoT applications. Now this is the latest trends or the applications areas where we have to just communicating with the help of wireless ad hoc networks. So I'm just also be integrating in these two parts IoT applications and the VANET. As the name suggests, vehicular ad hoc network. Because of we are just to be living in this intelligent transportation systems and just to be enabling all the IoT devices. It should be sensing or nowadays we have just to be used all this era. So I am just to be optimized because of where just to be identified these things, the problem definition. I just to be studying about the various research paper, and then it's to identify the what actually the problems that should be drawbacks in the existing work, and just to be identify the research gaps and just to be work on this Vanet communication process. So first of all I would like to be just demonstrating about each individual words how that works and has to be proposed all this works. First to be novel, I just to be implemented a new algorithmic approaches that should be make much more energy efficient work for the Vanet communication. This is to be complete hybrid because I have just to be integrated the number of two or more applications or to be the features that's extracted from the different routing applications or areas. And I just to be optimized because of it completely based on the routing scenario, the routing applications where I just to be optimize the best optimal path from the source to destination while the vehiculars make the communication which is good. That's why I just to implement this algorithm and also to be giving this descriptions about how the route is distributed in the different zones area. So this is basically the theme of my project. So I just to be entail with these snaps. Now first I am just presenting my outline with the help of the few points. First to be first I am just talking about my abstract, then the introduction about what the working or the going on the complete process, different kind of routing protocol that should be existing to work on this VANT communications and what related work I done, and the problem statement and the proposed work. What are the existing issues that should be existing in this VANT communication and what I proposed. Then I just to identify the main 6 objectives among these problems definitions, and then I just to be find out the research methodology. For that I have just to be use the network simulator as a tool to be simulate all these things in the area. So after that I just find the best result discussions to make our network much more stable, and I to be identify the various parameter on the base of the throughput, packet delivery ratios, many more things. So different parameters I just to be used and just to find the discussions, and after it the end I'm just giving the conclusions what I find in this research and what are the futures works about has done maybe in the works of the security concern I just to be working on it in the future. So now I just to be starts with the first abstract. Abstract I'm just giving you only the snaps so you can see nutshells the whatever the work is going on this complete whole process. Because of as the name suggests, the VANET routing protocol, the route distribution is the high traffic vehicle remains the major challenges nowadays because of because it's completely a vehicle that's communicating with each other, that should be travels on the roadside or the the vehicle that on the roadside or the highway side or the rural area. That's the different kinds of the communication that should be existing from because of each and individual vehicle that send the information to the next sender. So randomly it changes drastically changes their topologies. So this is the basic main issues that we have to find out this problem definition during this VANET communications. Because of its many times break the communications while just to be communicating or making the clustering or just to be transferring the information in the efficient time manner. So find out, second point is to be best find out the destination using the advanced routing algorithm with the intelligent transport systems to make the safety measures. So I just want to also identify because of its maybe in the safety features, maybe in the non-safety features. Because suppose the vehicle that should be driving someone is to be driving on the highway and that's to be identified the where's the petrol pump, the restaurant. These are all the basic applications. If we can identify visually with the GPS application we already use it. but no in the front of the safety, because of sometimes the intruder, attacker, hacker, crackers, they maybe send the intruder indirectly message to communication channels, then it may be interrupt the whole channel, whole communication, this will break down. So I just to be adopting some emergency algorithms that should be in very advanced, because of these algorithms or the routing protocols much more reliable. Why it's reliable? Because of from 12 sending the data from the source to destination, it will just to be giving the whole packages in the safe and secure manner to this destination path. So I just to be adopting different routing algorithms. As no, to find the response system in the simulation, because of I just to be all done work in the network simulator too, and I simulate and find the various results, and I proposed a novel hybrid optimization algorithms. This algorithm is to be called an E2HRC, energy efficient heterogeneous reclustering routing algorithms, or you can say energy efficient heterogeneous routing protocols, for that you can say. So it's much more energy efficient because of the saving the energy, because of each individual node while traveling or to be communicating with each other to consume some kind of the energy, some points of the energy. So the energy is much more important while just to be communicating with the next recipient or transferring data from source to destination. In that case, the various routing protocol adapt networks to be proposed, and for that the many routing protocols are also to be proposed in this recent studies as to be identified as A star, ant colony, artificial bee algorithms, and novel hybrid optimization in the case of you can say gray wolf algorithms, donkey smuggler algorithms, many more algorithms just to be identified based on this. If you're just talking about the base algorithms to be Bellman Ford, or the consider disaster prevention algorithm to find the routing or the network structure that should be created in this scenario. But how to be save the energy while transferring data from source to destination? That's why this is proposed. This base algorithms provide that. After that, sorry, just to be come with the first point. Yeah. Now, the performance of the ESF, because of I just to be the base algorithm, and this is to be a second algorithm where I have to be implemented work on this stable for the elections algorithm. This is to be an EARCHR, energy aware routing clustering algorithm, just to be an energy aware reclustering heterogeneous routing protocol, you can also say that. So energy has to be transmitted while there is a different collections point of view. You have just to be formation of the cluster. So I am just to be creating in the formation of the 5 different modules. So this modules having individual point of view just to find out individual steps on in each phases. So EARCHR, energy aware routing for the cluster head rotation, because of whenever it should be completed dynamically or the topological may be changed in the duration of the while they're communicating with each other to be drastically changed in the communication. So maybe any traffic that should be highway turns is there, or there's a driver side on the to be identified in the different clusters. So there are different cluster formations in the group. So one communication is break and transmit data to another communication. So in this case, say how to manage all this, and because of each and every time, if you're just not talking about the wireless, if you're just talking about the wired, in that case the different routing protocol, there's a distance vector and the linkage. The distance vector in the sense you can just to make the scenario on the basis of like that routing information protocol, EIGRP, open shortest path first, and enhanced interior gateway routing protocol, you can say the border gateway protocol, just to identify all these things in the wired communication. But if you're just talking about wireless, that means the energy is limited. So you just to makes this enhancement in such a manner that you have to save the energy and make this network stable for a longer period of time. So this is the best process in case they make the stable election protocol. So I am just to integrate this thing saying in our novel approaches. So identify these things, how much and more times it will be stable for the longer period of time. So this is completely I am just doing work on it. This is a hybrid technique, and just to be formations, just to be formation of the clusters, and just to be aggregate the function what the data collected from the different sources, and suppose there is number of the vehicle that is rotating or the moving on the road side or another side. So you can say I'm just to be collecting one information from the different sources, because of each and individual's a vehicle that should be integrated with some IoT sensors or devices that's having limited number of energy. Because of it just to be save this energy, and collecting the information, the routing table will be maintained properly. So after that maintain this routing table, suppose additions in the routing table is to be drastically changed. So I'm just to be relocating into the central points where the energy having the higher. So it's just to make the every time the cluster head will be changed. So I'm just to be repeating work on its approaches. So now topic first, I'm just to be introducing about all these things, what the concept is going on this process. Bipolar ad hoc network characterized routing that is power on the RPN, that's called low power and lossy network. So because of this talking about it, because of each in individual node we are just to be creating. On that times they having limited number of powers. So how to handle all these situations in the micro ad hoc network, I just to be giving introduction about the various types of routing protocols. So this will be categorized in the based on the proactive routing protocol, reactive protocol, hybrid protocols. So proactive in the case of we is talking about the DSTV, data destination sequence data routing. You can say advanced ad hoc data routing, temporary order routing, and John routing. So this is different categories that shows lower on that to be identified as problem definition. So optimal cluster number of each ring, that makes the size of the outer cluster ring than the inner cluster, because of the different number of cluster formations in this my process. So optimal, that means why should we do this work? Because to be optimize the shortest path from the source to destination. That's what we are just creating an optimal ring. This ring is to be every time created in the each and every process. So I am just to be given an especially the rotation of the head. Rotation of the head mechanisms is also to be applied on this low power and lossy network in the case of clustering. So cluster is also to be formation because of the different zones areas to be divided. So in this problem definition, I just to be created in this NH2 just to be like, and I just send finally I just what received is I'm just sending a 689 packets and just to be received 628 packets. The 26 packet will be lost. That aggregate I'm just getting this after simulations of this process or E2H algorithms or the ERCH routing protocol with the SAP. Okay, so I'm just to be getting all these things with this higher through output. High throughput that gives you the better efficiency as compared to the existing one algorithm. Say this is to be identified that side just to be get the better results from the existing one. So because of the main issues is to be discover the best path. To be discovering the best path, that's to be giving the based on the T best and G best value. Globalized, if we are talking about the simple basic routing algorithms in this case routing information protocol and distance vector link state. Suppose the number of from the source to destination sending some packets. So in that case, number of the nodes that should be counted from the source to destination. In that case, this is to be completely discovered. So this discovering process to be identified with the help of discovering process. So discovering, that means to find out the best route from the source to destination, because we have the multiple sources, we have the multiple routes. Because of every time the routing table will be updated, and just to be give this information to the cluster head, and cluster head send this information to the base station. By saving this energy conversion in this process, we just identify the best route discovery process. So if I was talking about the wire communication, in that case, what the link is bridged there. Suppose I am using the straight cable, two-shade pair cable, coaxial cable, optical fiber cable. So now I am talking about the discovering process in the wireless ad hoc network. That means we are just to be working on 802.11's B and G, like that, this kind of protocol. So it's complete wireless communication. So just to make or save our energy for a longer period of time, and to identify the best route from the source to destinations, because of every time this vehicle is not depends on the things that driver maybe change their moods and to change the route. So this is also to be identified the best way to solutions, give the optimized best solutions. Because of I was just talking about, you just heard about the hill climbing, steepest hill climbing, just to find the one solution. This is the second solution is better than the previous one, then you go for the next one. So this is the process for just to be like in the, discovering the best route process. Okay, so I'm just to be explaining all these things in this my next PPT. Now, this is organizational structure of my research methodology. Actually, first of all, talking about the Vanet. What's actually Vanet? Vanet, there should be different kinds of the routing formations or the technologies or the routing principles are there. So, this based on this categorization formations, different kinds of routing protocol, this is what existing was. So, different kind of routing protocols, and every researcher and many researchers do work on the individuals. But I just to be identified these things, the main areas to be save the energy while transmitting the data. So I just to be create a network formations, and just to be I just lay out the formations of my research. First in the first section I just giving the introduction, then Vanet routing protocols to my third chapter. That should be giving you completely different kinds of routing protocol. We have to study about all these concerns about the proactive, reactive, and location-based, geo-based routing protocols. That's just demonstrating on this field of chapter 3rd. Now, this is to completely overview of this existing work, that what the actual researchers do in this existing work. Though what I identified this, how to set the energy, and just to be implement these things in my NH2 simulator. So in the chapter 2, I just to be studied about more than 280 papers, research papers, and to identify these things. That's the work that is not done on the energy saving process. So I'm just to be do work on it. So I just to be created a modules for in the NH2. This I having the 5 different points. Suppose first is the network formation. Second one is to be the reclustering. data aggregation, vehicular node rotation with sync relocation and performance evaluation. So first of all, I was talking about the network formation. Network formation, just to me, establishing the communication between the nodes from the source to destination. This to be completely formed in the formation of the network. So how much layout is there, structure is there, how many number of nodes are there, how many number of ranges are there, how many number of zones are there, how number of clusters are there, and how many number of cluster heads are there. So to be identified with the help of network formation, first to be to form the networks. After that, reclustering. Suppose reclustering, that means restructuring, because of the topological may be changed drastically. So drastically change, that's why you be reclustering. Reclustering is the important process for that. To be restructuring the formation of the structures and to be make our network formation, whatever the exist, is to be make much more reliable or to be much more continuous with the terms. And data aggregation, that means to be summarizations of all this information, data that's collected from the different vehicular nodes. So we have just to be collected all this data and to be get this information, just to make the decisions which route is the best and the optimal source for the optimal route for the source to destination. And after that, because of it is to be identified on the basis of I'm just applying these algorithms in this process. Vehicular node rotation with sync relocation. This is a very important factor. Because of this is to be a swapping algorithm, just to be taking work on this process of the rotations of the node, because of individual node having the limited number of energy. So if the energy is to be getting less, then it's immediately should take overtake the actions by the another node. It becomes one is the cluster head, and second one is to be normal regular node. Then it's to be take over it this energy, is to be cluster head, and it's to be release these things, because of it also saving the energy. So because of which you want to communicate with the destination node. That's why we just process on the sync relocations. After that, I'm just to be getting the information from this experiment. Different kinds of the parameter I just to be taking in the matrix. Performance evaluations based on the throughput as to identify this is very good as compared to the existing one. All second is to be on packet delivery ratio is very good, and 20 timer is to be very good in this concerns. And I'm just denoting all this with the help of the graphical charts. Now, this is my system architecture, network formations, how to network to be formed in the help with the help of I'm just using my network experiment tool is the network simulator tool, and then I just to be identify the probability calculations because of the two kinds of the nodes we have to just to implement in this regular node and the advanced node. Advanced node, that means to be creating such a probability that's having the much more energy as compared to normal regular node. To be calculating the regions. So which regions that should be categorized. Suppose you are just giving in the different locations of the area of this vehicle node, communicating with this one central base server. So we can to make the decision based on their probability criteria. And this probability that's identified with the help of the updated routing information table. Now, energy aware clustering, because of which to be working on is the process this to be an energy efficient algorithm. We have to implement this to HRC, or you can say EAR WCR. This is the cluster head creations. After that, we used to make a end-user cluster head. That's on basis of these creations. We have just to be identified with the help of the G-best and P-best value. Because of various algorithms, you can do this work with the existing algorithms just to identify the best energy saving process in this complete whole process. And after that, just to be creating the cluster head. Cluster head is a main central node that should be having the medical system as a mentor of all these nodes. So it's having the information of all the directly or indirectly connected nodes. After that, we're talking about the data aggregations. Data aggregations means how to aggregate all this data in the field of to still be collecting the information from the different sources because of the drastically change. So topological change, the different nodes having the different tables. So this to be updating or collecting the information, or after that sometimes maybe the input data is giving the fact data on this process. In that case, to be also identify the saving the energy process multiple times to collect it from the different sources. But whenever it's sent it to the base station, it to be a workflow process on it and such to summarize all these things in this process. Next, neighboring cluster head, because of the cluster head to be changed drastically. So one energy is less, then they give energy to the next recipients, and there's to be increase the energy and just to be transmitted because of which to want to be not because of various intermediate nodes are also there. So sending from source to destination is also one of the process. After that, one kind of, you can say I'm just writing here the vehicular node or the rotation with sync relocation, the main process is there. Okay, and after that aggregation swapping, because of every time you just swap all this information or the exchange the energy level. So after that, I'm just analyzing this thing. This is my complete algorithmic process. This is flowcharts of this. How does this process work? And this is to be in completely flowchart. So network formation, route discovery. For the route discovery, we have to all having maintains the basic principle is that as to how to identify the best route discovery process based on the, if we're just talking about the ant colony algorithm, the pheromones to be sending different, and the one is to be intelligent or the smart art test, which is the normal art test to be identified the food or to be searching the food. In that case, the same process is there to be identified the best node in this network to be having the highest level of the energy. So this is to be a request, and this route is an individual process. Okay, after that, to giving the neighbors notice there. After that, number of the hop count in this process is to be identified ki how many number of hop count is there in this process. From that we can, as an intermediate node, to be collecting all the information. It's process called data aggregations, and this after that it is collecting some data method. For that's just to be formations of the number of nodes with individual setting the energy level. Okay, after that just formation of this clustering process, and then I'm just doing here applying for this relocations. I'm just applying for the two algorithm. But first is the swap level, second one is the swap rate algorithm. So this is the basic process of this application. So this is not only a single process, this will complete repetitions until the process is going on from the sending data from the source to destination. So this is complete an energy swap algorithm first, and energy rate swap algorithms first, and second is algorithm we have to apply parallelly. So this is completely after I'm just getting this performance evolution of this existing process work. This is all my related works, the destination directed acyclic graph, because if you know that is complete formation of the graph, and this is to be an advertisement distance, that is whatever distance from the source destination, or from the intermediate to the neighbor and neighbors to its destination's point of view. So we just to be transmitting and just to be identified with the different number of equations to be applied in this thesis. I'm just writing all these equations, whatever the process or the identify the energy level. So RPL is to be an remote processor packet locations and energy aware clustering algorithms are just to be balanced all these things. Okay, so this algorithm is the balanced energy consumption in the wireless ad hoc network, and to be considered of preventing some directly that gives the signal interference in crowded areas clusters. That means you can say different number of clusters to be formation in the different areas. So this to be identified by the individual balanced load with the number of zones. So E2HRC is the best searching algorithm. I just to identify with the help of P best and G best value. Globalized search, and for the individual members or nodes information that should be retrieved by the individual zones member. So this routing schemes gives the best performance in the throughput, time, traffic overhead, end-to-end delay, packet delivery ratio, balanced energy consumption, how much energy is to be consumed in the process and how much energy is to be left for this, and sensor nodes, and optimize the path selection and the route safety. These are all the basic parameters of the matrix you can say to be identified in the phase of performance. Matrix has also implemented. This is my proposed algorithms. Problem formations and the proposed solutions. What this main problem is that to be saving the energies. In this process, I am just to be applying this thing with the help of IMG simulator, all the thing with the help of network simulator, and just to be applying ERCHR algorithms to be the energy aware clustering algorithms, just to be integrated both the fields of the SAP stabilization protocols and ERCHR protocols. So I just to implement new one things to be identified in the near criteria. So this is my proposed solutions, and these are my objectives. Suggest the smart way to decide the best route for the vehicle based on the how much energy used and how much fast they are going on. So this is the basic things. Okay, first thing, I create a unique algorithm to combine the different methods to improve the way of the route divided among the routing protocols. This is also to be implemented, these things in, and studies of the how energy efficient work. This is a literature complete review I'm giving in this chapter 2. Okay, and do simulation study how well this algorithms works and how does it work, the performance evaluations, all the matrices, X graph, names, windows, and all these things. I just to simulate all these things exist as output, and determine how much better the proposed method is it the routing protocol compared with the traditional. Because of this is to be an already existing work is there, and just to be implemented the new, I find out the research gaps what the work is not going on there. So I'm just doing work on this better proposed method for the better results. So create a message system also to be set up the sending the hello package with the destination to be re-acknowledgement, the synchronization formations. So I'm just doing all this works in this process. This is my objective. root discovery process is basic concerns with, if you are just not, it's not limited, that's we are working on the Vanet. This is also applicable for all this algorithmic that you want to be search any route from the or optimized route. So this is the basic concern. You have to start check the destination node is present within the radius of the zone. If it is identified within the zone, that is the best solution, then it's okay. If it's not bad solution, then it's to be go for the next steps, and repeatedly it works all process going on there, and just to be identified the best destination node. If it's fine, that destination fine, and then we stop the process. Otherwise, it will forward the request peripheral to the number of nodes, and just to identify the best route or the best energy. This to be identified based on the only updated routing information table. So in this cluster head elections, I'm just to be saying this formations just to be in the form of head cluster. Suppose this is one zone, this is second zone. Here I used to identify the zone is either maybe the node number 3 and node number 4 may having the different number of joules energy. So if I just to be selected as in this regions, I'm just to be selecting in this formation like a cluster head. Because of the decimal change, maybe the routing efficiency will be changed in the different area maybe. So here right now the 1.32 joules energy is here, the 1.277. This to be cluster head, and this high probability that the cluster 4 becomes the next cluster head. So this is the formation of this cluster. Because of someone maybe the different areas instantly change, so lower energy will be changed. So it should be identified that's the different formation of the cluster. It should give the update to the next node. So it maybe gives the information like that's the which one is the higher energy at the last. So it will be becomes the cluster head. So it's the cluster head creation process is also there. So routing tree construction. After that routing tree that means not only talking about the zone, I'm just talking about the complete geographical area where the we studied all the ways to be implemented all this number of nodes. Suppose in my practical experiments, I'm just to be creating a 689 data packet I'm sending with the 100 area meters of the 100 nodes. So in this case, different zones or areas are there and to be simulated in the formation of the cluster because of it save the energy overall. So start node I calculates the cluster head value, and then cluster head only it's generate number of between 0 and 1. This to be identified with the help of the route circles, or you can say the formation of the iterations. So if the cluster head send this message to this next downward styles, or you can say in the formation of, you can say the flooding, my child to be the parents node because of having the number of childs or parents just to be like relations like that. So just to be make that if the better solution is found, then neighbors node will be update the information to his parents. Every time parents node will be get updated by this child. Okay, and send the master because of it will be identified with the help of their ID and the mask. ID means that means the number of name of the node, and child is to be how much number of energy they have. After that, the cluster had to be formation creations, and then it will be broadcast these informations to the next recipient of the next zone area. So it is to be the end of the process by the broadcasting the cluster head informations to this one. So this is actually energy of a clustering algorithm I am applying. This is the steps or I follow, and this is the simple cluster head election formation. Suppose it's to send a base station information while sending sometimes here is the, I'm just noting here the normal nodes are there, and here is the cluster head is there, and this to an base station. Because of this base station make the decisions on what the information they're getting from the end user cluster head, and the cluster head getting the information from the normal the regular nodes. So this is basically the formation of these clusters. Now in my algorithm, I just to be creating the response set. First of all, I am setting in the network simulators. First of all the nodes are becomes white. So they have to not identify any formation of the cluster that's not part of any network. So at that to be sit in the ideal mode. So this to be an algorithm node which initiate topology discovery request the color as black. After that, whenever is to be formation of the cluster, this to be identified the that's node in this formation of the network. In that case, it becomes black. So it's to be having some few energy. So it's just be getting the energy and just to be form the network in the region. Suppose I'm just creating the group 1 group, 2 group, 3 group, 4 group like that, and all the white nodes becomes a gray. Whenever after that, so, or if the nodes are getting the black, in that case after that it's just to be reaching out and mix the energy or make the decisions on the basis of broadcasting this message sent to the all ideal node. If they are just white node, rest of all are one is black node to get the energy and they form the network. And those who are not getting the formation of the network, this is on ideal, this is a white node. This black nodes get activated after sending the message to the all neighboring nodes. So all if they are just to be getting from the white that means it's still ideal, but it's just to be getting the gray that means to be gray this formation of this new transformations mode. So you can say it's to be a energy efficient algorithm. So white node becomes receive the packet from the gray node. After that, all are node ideal because it to be get activated. Gray means active node. This to be based on the distance or based on this like cluster head. So means time it receives any packet from the some other black node. Also to be getting the information, dark node, black node. If it's to be again getting the black, there's to be repetition words that's there. And after all is to find the request that has to be received. Gray node, that means to be identified, that's its complete formations are to be created and saving the energy. If the black node to be gray, continuously giving the energy to this black node, that means to formation of the cluster head. So it's will again transferring the energy to the next level. Next level it should be changed drastically. So it will be black and then gray. The importance that's to be make either direct is not white to black, it's direct to white to gray also. So second phase, the top discovery mechanism. Because of the network formation will be changed. The network formation change, the first phase of algorithm set up this node formation of this white node, black node and gray node. After initiating the node becomes the root of the black node. After in this black node, who's having the highest energy level energy is to be becomes a black node. This to be parent, just to be treated as the parent node, and having the number of rest of the black nodes to be treated as child node, and also generate the energy for or transmitting the energy from the next neighboring black node. So this process of the parent black nodes, which is the last black node, and which is topological discovery, and forward to reach out, which is the next destination find in this scenario. So to be created the energy or splitting this energy in the number of nodes, and which to be identified, detected, it's to be white to either gray or white to either black. So this is our second discovery process. After using this information, the step top disk management. Top disk means you to just balance the energy level. To balance the energy level, for the balance the energy level, the node becomes black. It sets the timer. Because of each end user set the timer. If it's not setting the timer, it's not identified how much times of energy it becomes continuous transmitting data to the next recipient. Otherwise, it will be having less energy. It will not able to transmit data over the so it not to be activated another white to gray. So black node is also having the limit time and to set individual timer for individual nodes. So the aggregating of all level, after that should be formation. Suppose the network forms also to be created. In that case, it to be aggregated. Aggregated means collecting all the information from this black nodes, and that's to be splitting all this information to the respectively broadcasting the information to the white node, and so white node becomes the gray node. So the timeout, all forwarding nodes between the black nodes may also be at the adjacency, because of it also be creating the intermediate node, which is to create the adjacency list for this. End user routing table also maintain this record. After that, timeout of the children black node should always be expired before the parent node. Because of it will be continuous sending the energy, it will becomes the less energy. So it gives the update to the next recipient. It becomes now again ideal, black to again white maybe, or it's maybe gray. So if you are having still energy, then it continues broadcasting. If it's not getting the enough energy, then it will broadcast energy to the and make the choice probabilities on the basis of the energy level gives to the higher authority to gray node. So gray node becomes also to be in a constructions in the tree formation of the cluster head. This to be process is called a tree of cluster. There's a formation of the tree of cluster to be created. After that, in the process going on there, the different number of clusters created, number of clusters created, the clusters formation. So individual clusters having also the communicating with the other clusters. So I'm not talking about only the individual nodes, I'm talking about the complete cluster. The cluster is complete group of formations, and this group having communicating with the next group, and each individual group having the over best energy level cluster head. This is to be a gateway. This process to be called gateway, to be communicating between the number of clusters. So this is the second phase. Suppose this is the base station, cluster 1, cluster 2, cluster 3 are there. So in all individual hand, these are the basic node, because suppose it are white or the ideal. In that case, this information for with the process of the formation of the cluster, it will send the information to all them. It's maybe either if they having the activate in the formation of this network or the structure. In that case, it will becomes either gray or the black. If it's not, in that case, suppose in this case here I'm sending information to becomes a black. In here case maybe in the gray or the white, it's maybe an ideal. So now it's not, if individual nodes are putting in this area, in that case maybe or may not be a white. So this is to be sending the base, and base doesn't make the all final decisions based on their performance. And this is a complete process whatever I'm just to be sending in this talking about in the previous sections, to be data aggregation, the collecting the information from the each individual cluster formation and the cluster head. That's information that should be setting the process. And then these are the basic 5 sections. Analyze the data sync, Okay, hop count, number of hop count, how many number of intermediate node are there, static forwarding node, and point of proposals. That means what the next point is to be going on there. Then static point of appraisal. So dynamic or statically it will be changed. So static, that means constantly will change. Dynamic, that means to be rotating in the formations of the different number of clusters head. So vehicular node rotation, this is the basic binary steps where we have to swap the energy level from the one node to another. If you have less energy in transmitting, and then it will overtake by the another cluster head, and it becomes the cluster head. Now the next one it becomes the cluster head. So cluster head will be released, and this becomes again black to white, and just to be consume some energy, and just to be swapping or re-energize with the ideal process. Okay, after that, just to be getting performing this analysis, I just to be identify the different algorithms, because of leech is also one of the best algorithms in this process. So I just to identify comparing with this number of energy swapping level. So energy network energy consumption, how much energy to be consumed. So the leech on the times I just identify leech is the best protocol for that. So DDR and different writing protocols to be identify these things. But after that, as we proposed algorithms, as to be identify this, they have a comparison average nodes. If I just to be creating number of nodes like that, so 1600, and the number of the energy that should be consumed in the joules. Okay, so as to be identify the proposed algorithms on the basis of the one of the speed is basic algorithms. Okay, and just to be comparing with the existing one, all algorithms to be identified that the best energy gives by the energy consumption, because of you just to make the stable our network for longer period of time. The EERCH is the best algorithm for that. Okay, so I am just to be on the slides PPTs. This one now, and packet delivery ratio with the RPN, loop over and lossy network, with the help of E2CR algorithm, actually comparing with the algorithm to simulate all these things. So number of nodes, packet delivery ratio, these are the basic two-sided, and 20 packet on the basis 30 packet, 40 packet per minute, 60 packet per minute. So this is an original RPL algorithms, that is existing one. So this is basic algorithm, but after this, to be implementing all these things with the help of E2HR algorithm, just to identify that's the packet load ratio becomes very less. So packet delivery ratio becomes very less, and you can say the energy efficiency to also be increased, the throughput also increase. And after that, I'm just to be comparing with the routing protocol, the control packet ratio. Control packet means transferring per unit times whatever the number of packets sent from source destinations in this area. So RPL and E2HR, I'm denoting with the second graph. This is my network formation creation. Suppose here I am just to be creating here a nodes. Okay, this is 99 number is our base station, just to be communicating with all this process. I am just packet send is 1660, packet send is this 1669, packet loss 39, first phase, and the remaining energy becomes this one, and energy difference is this like. So this is the creation of the formation. Suppose a number of nodes are to be created in this region or the area, and formation different number of the clusters, and someone to be in the ideal black or gray nodes, because some guys still to be and not in the any region, that is to be completely white node. When it will get activated, or every time the energy will be swapping to each other node. So I just to identify these things. Say 99 number is our base station to be transmitting with the different regions, to be communicating with a different number of regions with the help of cluster head, sending the informations and all these things. Okay, so this is my practical experiments of all these things. Now average throughput I'm just getting like this one, generated packet 657, this is packet 588, and average N12 delay is this one, and 89 is this, and total drop packet is 55. This second experiment I just did on this performance. So I just to identify the average delay calculations to be also good as compared to the another one. So N20 delay is also to be very in this experiment should be identified as good as compared to other one existing. Okay, now the energy consumption also to be identified with the help of, I'm just comparing with the RPL, E2SRC, ERC, the protocols to be integrated both these features in this one synapses or individual also to be identified. So this is my parameters. Okay, end-to-end delay, end-to-end packet delivery is how much is to be graphicals, noting here the ERC is giving the best performance in this concerns. Okay, on the basis of the less energy consumptions. Okay, and packet loss calculations is also to be good. Okay, now simulated with a packet delivery ratio PDR, packet delivery number of time completed, how many number of packets are transmitted from the source destination in this concern is to be also to be recorded. Now putting the overhead calculation, if the traffic load is too much increased, and then how much overloaded or the handles in this process by with the help of V2SCH and ICS. This is by or basic algorithms. I am also comparing with the individuals. Okay, and just to be remaining number of energy also to be calculated with the help of the X graph. and G0 outputs also to be throughput calculations, also to be graphics representations of this. The throughputs also to be increased. Now, I just to be identified this based on this experiment to conclusions that the EACSR, the clustering, energy aware clustering aggregation rotation with sync locations. I'm just to be putting these names after that. So, this protocol energy that should be happen with the concept of reducing the energy consumption and with low health test communications. And in this design, as implementation supports the graph effect that substantially improve the pocket delivery ratio, strongly proposed algorithms provide a more robust and dependable data delivery. To be enhance this performance, contribution in the terms of quality of service, reduction of communications, lower overhead, improve overall network reliabilities, and making promising choice of vehicle ad hoc network in this area with a high quality and reliable data transmission. This is my conclusion to be identified. And in the future, talking about this communication is to be work on these security concerns. If it's to go for the works on overhead, the security in the environment monitoring, protections of the data, and keeps the network well. So maintain the stability of the network again, and the security is my future work. These are all my the references whatever just we put on this slide. So these are the basic references whatever the different routing, because I have to be studied about more than 280 research paper or the articles or the work or the research work, and it's my published research paper journal that should be identified. Okay, these are the before my study or journey. After that, I should be working on this research paper and just doing the journey of this research work. Okay, now thank you everyone. Now if you have any queries, then please ask. Thank you very much.